Time is a really interesting topic because in a strange sense you can make the argument that time both does and doesn't exist. It was Albert Einstein who shed a lot of light on the idea that space and time are intertwined in an infinite fabric called spacetime. Yes, super creative name. In spacetime, the time that an object experiences is heavily dependent on that object's motion and the space around that object. If an object is under the effects of intense gravity, or if an object is moving incredibly fast, or both, both works as well. If an object is under either or both of these effects, then the object will experience a warp in space-time through time dilation. So let's say that you have two clocks. One is stationary on the ground, and another is, I don't know, let's get some sci-fi in this. Let's say another is in a starship moving close to the speed of light, or something super fast. It's moving incredibly fast. Now let's say that both of those clocks were set to count 10 seconds starting at the exact same time. The clock in the starship will reach the 10-second mark at a later time than the stationary clock. The stationary clock will reach 10 seconds before the starship clock. This is due to time dilation. Now, the people in this starship will not realize that the clock is behind the stationary clock. And the reason why is because this warp in space-time is completely relative. There have been many experiments testing the effects of time dilation, but just for the sake of this video, I'm only going to bring up two very famous ones. In the year 1971, the Hefele-Keating experiment was conducted, in which two atomic clocks were placed onto planes, and one clock was kept stationary at a lab in Washington. Now, these were not just ordinary clocks, these were atomic clocks. The difference between an atomic clock and an ordinary clock is that while an ordinary clock will count based on seconds, an atomic clock is very, very precise, because an atomic clock will determine time based on the vibration of atoms. The atomic clocks that were on the planes went in two different directions. One plane went east, the other plane went west. And the results of this experiment were really interesting, because what they showed was that the east moving plane actually lost time on the atomic clock, and the west moving plane gained time. The first thing you can pull from this experiment was that the motion of an object directly affects the rate of change of the time that that object experiences. But there was a question. Why is it that the west moving clock gained time? If time dilation occurs, shouldn't both clocks that were on the planes have lost time? Well, there's a very important factor being left out of all this, and that factor is gravity. Basically, the western plane was actually a bit higher in the sky than the eastern plane, and because of that, the western plane was actually experiencing less time dilation from Earth's gravity than the eastern plane. And it was also experiencing less time dilation than the stationary clock, because the stationary clock was both experiencing the full force of Earth's gravity, and it was also experiencing the motion of the Earth rotating. So although the western plane was moving just like the eastern plane, the western plane experienced less time dilation. In 1976, scientists at Wallops Island conducted an experiment called Gravity Probe A, in which a rocket was launched up into the sky carrying, you guessed it, an atomic clock. The probe was sent 10,000 kilometers into the sky before crashing down to Earth. Now, what scientists found was that the atomic clock's time had changed. Now the reason why is because when the atomic clock went 10,000 kilometers into the sky, the atomic clock was under less of the Earth's gravitational pull. And because of this, the atomic clock was able to register more time passing. So these two experiments together show that the time an object experiences is directly affected by an object's motion and by the gravity being exerted onto the object. So with both of these experiments in mind, you might be asking the question, well, what time is correct? I mean, is the time we experience on Earth correct? Is the time in space correct? Is any time correct? The answer is yes. The answer is that all of these times are correct because time is relative. These experiments show us that time is not a universal constant. Time is subject to change when introduced to mass. Now the other thing is that space is also subject to change when introduced to mass, which we can see through the effect of gravity. So this just further pushes the point that space and time are intertwined. They literally change together because of the same things. So where does this leave us? Does time really exist, or is it just a human construct that we created and that's it? Are time and space literally the exact same thing? Well, what's funny is the answer to these could all be yes, but at the same time, the answer could be way more complicated and we really don't know the final answer. Technically, you could just say that time does exist and it is the events that occur in space. You could also say that time is just a human construct that we made for how we experience space. You could say that as well. It's all very, very confusing. A problem that humans face with this is that the human brain isn't really built to fully understand space-time. We experience space-time from a very subjective view rather than having a full objective view of how space-time works across the universe. This is one of the reasons why we use mathematics to understand the universe. We don't have access to that objective view of the universe, so we have to use tools like mathematics to get the best glimpse we can into the objective view of the universe. Without mathematics, we really can't understand much about how the universe works at all. Thank you all for watching. If you enjoyed this video, please leave a like and subscribe to the channel. And if you have any questions or disagreements about the video, or agreements about the video, feel free to leave a comment. So what do you think about time? Does it exist? And if so, what exactly is it and what is its nature? Do some research on this topic. And of course, never be afraid to ask questions.